Welcome back to Sairam Tribuli YouTube channel. Let us discuss Module 1 representation of power system components. In that we have impedance and reactance diagrams. So whatever the power plant single line diagrams or all the power system components we are representing in the impedance as well as reactance diagram. See, the name itself indicates impedance will be there and reactance will be there, right? So the basic definition of impedance is which avoids AC current, right? Impedance Z. So it must have R plus JXL or R plus JXC. So it's a combination of resistance, active component, and then reactive component. Either it may be a inductance or capacitance, right? That's imaginary. So even though from the first years of engineering, we used to have R plus JXL, R plus JXC. What is that R and then what is that XL or XC? So R is a resistance. It's an active component. It consumes the power. Keep it in your mind. And next there is a JXL or JXC. XL is an inductive reactance. Energy is stored in the form of magnetic field, right? So that's imaginary. Even though for JXC, I mean capacitor R minus JXC, so energy is stored in the form of electric field. That's a imaginary. So that's why we are using imaginary. So we don't know if suppose there is a magnet present. So how long it is the magnetic flux lines will be distributing or attracting or repelling. We don't know because that is imagination. So that's why R plus JXL will be there, R minus JXC will be there, right? So that's the impedance. And then reactance diagram same. In the reactance diagram, we are eliminating all the resistances in the circuit components, and then only we are keeping reactance in the power system components. That's why it's called as a reactance diagram. See here, the first one is basic symbol. It's very important, basic symbol. So I already told you, basic symbol you must practice for the understanding of question as well as for answering also. Next, impedance diagram replaces three phase to single phase, right? See here, why? Because for generator or motor, whatever it may be. So transmission line, if you take calculation part for three phase, if you calculate only one phase, all the three phase values must be same, right? I mean like other two values must be same. So that's why it is three phase is converted into, I mean three phase parts or components all we are converting into single phase, because the phases are same. It's a balanced circuit. The phases will be same. All phases will be same. For calculation point of view, so we are converting into three phase to single phase, right? Next, transmission lines, pi model will be there and T model will be there. So in these transmission lines, we have a long transmission lines, medium transmission lines, and then short transmission line. Short transmission lines, keep it in your mind, 0 to 80 kilometers, 80 to 250 is medium, and above 250 we can consider long transmission lines, right? And next there is a transformer equivalent circuit. So we have a single phase transformer and then three phase transformer. Again, three phase transformer converted into single phase circuit, right, for the calculation point of view. And load, its impedance. So load, either it may be motor or static load. Static load in the sense stationary, okay, keep it in your mind. And then dynamic load in the sense motor, okay. Reactance diagram omitting RC and IM and magnetizing component, and then this one IC active components, right? So we are going to omit the these two parameters. So next we have single line diagram, okay. So power system components are represented in a single line. So wherever you go, I mean like you visit any power plants or substations, they used to display one single line diagram for how many incoming lines are coming to the substation, how many outgoing lines are going from the substation. Basically, in the substation we will get two incoming lines. I think you can ask me the question. I mean, why sir? Two incoming incoming lines, right? So one is for alternative purpose. If suppose one is not working, I mean like one is failure occurs, automatically second one will switch over. So that's why we have a two. I think you can go for industrial visits, any power stations or substations. Definitely you can see two incoming lines from one power plant and another one power plant. One, for example, I'll tell you, one Sharavati power plant, Joga, there is a hydel power plant is present. Another one is there is a thermal power plant or Ballari thermal power plant. So from there also we are I mean power we are utilizing in the substations point of view. So there is a two transmission lines, right? So power system components are represented with a single line. That's why it is called as with the symbols. It's called as a single line diagram, and interconnection of single phase basis. So I told you already, three phase is converted into single phase because calculation point of view. Not only calculation, because three phases, all the single phase must be same. So that's why like this. This is a single line diagram of uh, this one power system components. I just consider this one is a Raichur power plant. Okay, generator will be there. So there is a step up transformer. See here, but in this diagram they mentioned a constant transformer. Don't consider this is a constant transformer. This one is a step up transformer. Keep it in your mind because very important. But you should not draw this diagram if suppose somebody will ask question. You draw the single line diagram of power system components or some single power phase AC power system or from power generating station to your home. Just you draw one single line diagram. So there you should use here step up transformer. Keep it in your mind. Next there is a transmission lines over here. So the long distance will be there. I mean from Raichur to this one is Bengaluru substation. I mean Vijayanagara, or just to consider nearby your home also. Okay, but it's not a distribution feeder. It's a distribution transformer. Usually we will be having in substations. Okay, transmission lines will be there. It's either it may be a short, medium, or long transmission lines, right? So this one is a step down transformer. Next, there is I told you right. There is a motor present utilization. See in this diagram, so it covers all the power system uh, phases. I mean power system parts. First one is generation, right? Generation will be there, and distribution will be there here by using transformer, and transmission will be there, and this is the utilization. So four part: generation, distribution here, and here there is a transmission, and here there is a utilization, right? So there is a star connected with neutral, reactance grounded, and then resistance grounded. So these are all the symbols. Okay. Mm. Uh, next we'll see. Next we'll see. Next we'll see for the three phase system. Real time diagram is very complex. Many number of components are present. So if it is three phase, many number of components present, right? So we have to draw three diagrams like this: one diagram, two diagram, three diagrams. That's why the advantage of single line diagram is this one. So many number of components are present, and then three phase system real time diagram is very complex, right? And for the calculation point of view, we change the three phase system to a single phase system, and all the components are represented in certain symbols, right? For single phase representation is easier, okay, for single phase. And you can answer for this question, why, I mean what is the one line diagram. See here, power plants, all the electrical symbol of power system components, electrical components in terms of single line or in terms of single line with symbol is called as a single line diagram, right? So there is a power plant. Just to consider this is the power plant. These are the like see here, both renewable and non-renewable will be there. So these are the power plants, and then step up transformer over here. This one is a transmission network, and this one is a distribution network, step down transformer. So particular area, particular home, they'll place each step down transformer over here. Here also step down transformer. This is also step down transformer, right? See here, from here to here, just example, 11 kilovolt to 220 kilovolts or 33 kilovolts. So 33 kilovolts are again converted into here 11 kilovolts. Again here 11 kilovolts to 415 volts are 230 volts single phase each home consumer side. So generator, transmission network and distribution, right? It's a concept.